So let's start talking about the very important idea of length. So first let's try to get the idea of shorter and taller across. So shorter or shortest and taller or tallest across. So for example, here we have um, here we have three bars, the white bar, the blue bar, and the red bar, and we want to figure out which one is taller or shorter and things like that. So let's say we're trying to compare maybe the white and the blue bars. So if we try to compare the white and the blue bars, so we have to tell them what do we mean by being tall or short. So intuitively they know that if two children are standing on the same ground, and if we measure and if we look, the one whose head is higher is going to be taller, and the one whose head is lower is going to be shorter. So that's the intuitive idea you want to give them. The second idea you want to give them is that if the shorter child stands on a stool or something or a chair, he or she can become taller than the other child. But we don't measure length this way. We have to align one of the ends to be the same at the same horizontal distance, at the same horizontal height, and then we compare the heights, and the one which is higher is called taller and the other one is called shorter. Similarly, if you put the blue next to the red and you make sure that the lower ends are aligned, then the red is taller than the blue, or the blue is shorter than the red. And now we can also compare the three, so that would now be shortest and tallest. So again, out of the three, we can see that the red is the tallest and the white is the shortest. So that's one, just the idea of the intuitive idea of being higher or lower is being captured in these words. So now we also want to give them the idea that this length can be measured by pure counting. So here you can see, right over here, you can see that there are blocks and you can count the blocks. So first what you do is you put the blocks together and show that the yellow is the shortest, and probably the blue, let me count. So let's first count. So it may be better to count instead of guessing. So if I count the yellow ones, there are 4 blocks. If I count the red, 1, 2, 3, 4, 5, 6, there are 6 blocks. If I look at the green eye, 1, 2, 3, 4, 5, 6, 7. And if I count the blue blocks, 1, 2, 3, 4, 5, 6, 7, 8. So now you can clearly see that the yellow is the shortest and the blue is the tallest, and you can also put them next to each other. So before you count, you put them together and show them that the yellow is the shortest and blue is the tallest, and then you also do it through counting. And you have to get this idea across, and this is what I'm trying to do right over here, that for example, if you're trying to measure the white bar, I have a lot of gray bars, and that's how I'm going to measure them. And please note, first you have to convince the child that all these gray bars are the same length. That's the first thing. Now I'm going to see how many gray bars fit into a white bar. And I'm just trying to put all the gray bars together. And I think about 4 gray bars fit a white bar. Okay? And now if I want to find out, so this length would be 4. But now if I want to find out how many of the gray bars fit into the red bar, now you can imagine, and this is what I want you to do, I want you to imagine that how many gray bars would I require to fit into this red bar here. And hopefully the answer is that the kids will say the answer is 4. And if they're not convinced, show it to them that the 4 gray bars will fit into the red bar over here. And now what we can do is that I can start putting in more gray bars, and you can see that about 3 more gray bars fit into the red bar. So that means I need 3 more gray bars. So the total is going to be, so red is going to have a total of 7 bars, whereas the black had a total of 4 bars. And you can also see by doing the same thing that the blue has a total of 5 bars, that fit into the blue bar. And then you can again repeat and give the same idea that counting is an effective way of measuring how tall or short somebody is. And now, after getting the shortest and tallest and shorter and taller idea, also relating it to counting, now what you can do is you can also talk about longer and shorter. So now we can have longer and shorter, and similarly, you can have longest and shortest. And what you can do is you do it with the horizontal bars and use the same idea and show that measurement can be, it's an important idea that this intuitive idea of being shorter or longer can be captured by purely counting. And this is the idea that I want you to get across, that these gray bars, and now you can put them horizontally, allow you to count the length of a bar right over here. Okay, so the same ideas for tall and short get repeated for longer and shorter. And now the big idea is that we can use, so we are really thinking about counting. It's an important idea that by counting, we can really measure the length or the tallness or shortness of an object. Okay, so now when we encounter problems, so this important idea is used when we come to problems like these. And here we really have to start counting. So for example, we have to figure out which one is longer and which one is shorter. And one way to do it is, so we'll do it two ways. So one way is that actually I'd get a child to walk on a grid and start counting. So if you start counting on the grid, so you're standing on a grid, or you can imagine something on a chessboard and get a child to count. So you really have one. So this is what I would do. A child would be taking the first step, the second step, the third step, the fourth step, the fifth step, the sixth step, the seventh step, the eighth step, and the ninth step, right? There are 9 steps, okay? And now if you think about what happens over here, there's the first step, second step, third step, fourth step, fifth step, sixth step, seventh step, and eighth step. And if you want to think about this one, the last one, then you'll have the first step, the second step, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth, and the 10th. So clearly, this one is the longest, and this one is the shortest, right? And now, but you have to get this idea across that we can get this idea of length through counting. You can also use a string and then put it on the board and then extend it and show that the string is 9 units long or 8 units long or 10 units long. That's capturing the intuitive idea. But I really feel that if you had a large enough grid on a floor and you actually got the child to count, they would really get this idea across that the length is really a measure of their steps, and that would be a good way to think about length, how far something is, how much distance are they covering, okay? So another problem that we might encounter is that here's a problem, and they want to figure out which tape is longer and which tape is the longest and which tape is the shortest. Now you can see there's a problem here that between P and Q, it's very easy to see because we can just purely count. So if I just count, I get 1, 2, 3, 4, 5, 6. And for Q, I get 1, 2, 3, 4, 5. So clearly P is longer than Q. That's easy. But R is kind of confusing, right? R is sort of at an angle. And now they have to understand this idea that being at an angle gives us a very confusing answer, because at some level, I don't know how to count, because here the strips were perpendicular to the bars, so everything was clear. Now the R is no longer perpendicular to the strips. And it's not very obvious that we should just simply count, because if I just count, for example, I can look at maybe 1, 2, 3, 4, 5, 6. It looks like that this is about 6 strips long, and it seems like P and R are equal to each other. But now if you were to, before you even did anything like this, if you were to just look at the bars, you'd actually see that R looks longer than P, so R probably ought to be the longest one. But now what we have to do is we have to get this idea across that changing the angle makes the strip look a bit different. So let's get this idea across. So you can see right now that my white bar is 1, 2, 3, 4, 5, 6 squares long. But now, and the squares were really, I can just write down 1, 2, 3, 4, 5, 6. But now what I can do is I can start to rotate this bar, and if I rotate this bar enough, um, let me even rotate it even further, and I can put it like this. And now if I were just to count the length, please note I'm just counting the length. So if I were just to count the length, I'd get 1, I'd get 2, I'd get 3, and maybe 4 or something like that. So the length seems to be changing, but that's not right, because the length ought not to change, because that's the amount of walking that the child was doing in some sense. So the length can't change. So what we were doing was that we are not measuring it in the right way, but we need to rotate this bar. So I'd actually take the red bar, rotate it, and show it to them. So you would cut out the P, Q, and R bars and put them all together side by side, more like this. So this is what I would do. I'd put the bars next to each other and then show that maybe this would be the bar R, this would be Q, and this would be P. So you would really show that R is longer than Q by actually putting things next to each other and showing which one is longer and which one is taller. And the reason why counting is not working is because you're just showing right over here, you showed them that by rotating and simply counting how many vertical stripes is the bar crossing is not a good measure of how things are. Another way that you could talk about it is, for example, here's a line. Let's say you want to measure this line, right? So the way I'd measure, because I'm actually walking next to the line. So if I start, let's say I start from point A and I want to walk to point B. So the way I'll walk through point A to point B is, this would be my first step, this would be my second step, and this would be my third step. So I'd be taking 3 steps to go from A to B. Now, if I were to actually, I could imagine rotating this and making it horizontal, right? But if I keep my things vertically, I don't rotate my measure. So this is kind of bogus, because what is happening is that I am actually not walking the same distance, I am walking a different path. So in order to measure it correctly, I have to rotate my objects also, and showing them that if I were to rotate my objects and make them horizontal, I'd be measuring the same distance. So now I'm putting them together right over here. I'm trying to align them with the bar, and you can see, hopefully everybody can see, although I'm a bit inaccurate, but if you are working with physical objects, you can probably do it in a better way, that the length is invariant and it doesn't matter at which angle the red line was. The red line is still 3 white bars long, and that's an important idea that you want to get across. So I would really get this idea across that we have internalized in our own heads by playing with the child and doing some experiments by holding physical things and making the child walk around and intuitively feeling this idea, capturing this idea of length.